So what we're going to do today is we're going to finish our last unit, which is on probabilities. And the very first thing that I showed you was a video of a guy who didn't understand that anything closer to zero is basically not going to happen. The chances of rain today are very, very, very low. So the guy, when she said 1 out of 100, he said 1 out of 100, she said 1 out of a million, meaning that is even a farther chance than 1 out of 100, and so he didn't quite get that. Anyways, anything close to zero is unlikely to occur. Anything close to 1 is very likely to occur. You can have a probability of 0. You can have a probability of 1. 0 means it's not going to happen. 1 means it is definitely going to happen. And you'll see some examples as we go through this worksheet today. So let me see what I have here. The probability is going to be abbreviated to a P. If you see a question that says P of an event, that's asking you to figure out what are the chances of this particular event happening, and they'll be very specific, and I'll show you what I mean. Answers can be written as 0, as a fraction, as a decimal, or percent, and I prefer reduced fractions in lowest terms. The very first words that they ask you to find is something called the sample space. If you've never heard what the sample space is, it's the set of all possible outcomes. And so they start you off with something called a number cube, or like a die, a single die. It's called a number cube. You could roll a 1, a 3, a 6, a 4, and so on. So if they ask you to find the sample space of, let's say, a die, then what you're supposed to do is you're supposed to write out the possible outcomes. For example, if you were to write the outcome of 1, 2, I'm not going to be able to write today, apparently. It's not working. If you are supposed to write out the possibilities, you would write the numbers 1, 2, 3, 4, 5, and 6, because those are the possible outcomes. The other thing that you're going to have to do are Venn diagrams.
So we don't have to put the percent of each outcome?
No. All it asks you on is like a number 1 is it's asking you what's the sample space for a number cube. You could only have the possibility of rolling a 4, a 6, a 3, a 5, a 1. And I would just say write them out in order from least to greatest. The second idea you're going to have to do are dealing with Venn diagrams. Sometimes Venn diagrams have 2 circles that are separated. For example, people in Math 1 are not in Math 2. People in Math 2 are not in Math 1. I've never really had somebody in Math 1 and in Math 2 at the same time. It's possible, but I've never had it. You're either in Math 1 or when you pass that class, you're in Math 2. Those would be 2 separate circles. But it is possible to have somebody in Math 2 who is also in English 9 and somebody in Math 2 to be in English 11 or English 12, right? We have juniors in here and seniors in here. We might have some people who are in English 10 and English 11 who are in Math 2. They might both be in Math 2, so you would have an overlapping event. That's what would be shown by having one circle over another circle. The hardest part about a Venn diagram is figuring out who's only in the English 10 class and who's only in the English 11 class. Those are kind of tough. When I'll explain that in problems 4, 5, 6, and 10, I have 2 examples picked out for you. So here we go. This is number 1. You guys have the worksheet in front of you. Let's talk about how to do these questions correctly. What is the sample space of a 6-sided number cube if it's rolled 1 time? Like you could get a possible a 1, a 2, a 3, a 4, a 5, or a 6. That's what you write out here. There are 6 possibilities. 1, 2, 3, 4, 5, 6. So just write it out. I'm going to have to do something slightly different than I've done before. So let me just write that down. 2, 3, 4, 5, and 6. That's what our possible outcomes are. The second question says, find the probabilities below. See how the P is there in 3? What they're saying is, what's the chances? What's the probability of rolling a 3? You can use your sample space by saying there is one chance out of how many to get a probability of a 3. And I'm hoping you know that it's one possible way to get there out of 6 different possible outcomes in our sample space. 1 out of 6 is the answer for probability of a 3. What's the probability of it being even? Look at what even numbers you have. You have a 2, a 4, and a 6. That's 3 chances out of 6 possibilities, but write that answer in lowest terms. The probability of it being even would be 1 out of 2. I'm hoping that makes sense to you. That's why we put it in lowest terms, because there's a 50% chance that that's going to happen. What about the probability of having a number or rolling a number that is less than or equal to 6? This is less than or equal to 6. So is 5. So is 4. So is 3. So is 2. So is 1. The probability of a number less than or equal to 6 would be 6 out of 6, otherwise known as 1. We always put it in lowest terms. Going into that, what's the probability of rolling a number less than 10? I bet you guys know what the answer is. If you think you know what the answer is, say it out loud. You said it right. If you said 1, it's 6 out of 6, or 1. Good job. So that brings us to our first Venn diagram, which is number 4 that I want you guys to look at with me. Number 4 says, within a track team, there are 15 members who run sprints, 10 members who are long jumpers, and 6 members who run both sprints and long jump. Now, sometimes these things are going to be confusing. Don't freak out. Or maybe I should say, don't jump ahead of yourself and start adding up the numbers. The first number that is the easiest one to figure out is who runs both sprints and long jumps. So this is how I'm going to organize it. I'm going to put this here, and I'm going to put a little Venn diagram like that. And above this one, I'm going to say these are sprints. And over this, I'm going to put long jump. That way I have sprints over this circle and long jump over this circle. There are 6 members who run both sprints and long jump. That's the easiest one. Do the both first. 6 members who do both. That goes here. There are 6 in both who do the long jump and their sprinter. But that's the same 6 people. Like, we can't count them again. So make sure we know that. We're not going to mess things up. When they give you the 15 who run sprints and the 10 members who are long jumpers, those are combined totals. That is the reason why in your notes I mentioned this. You are given totals. These are combined totals of the both and the only. Well, what does that mean? That means this. 15 members who do sprints. It's the 6 people who do both plus something equals the 15 members who do sprints. It's a combined total. You got to figure out what goes here. Who does sprints only? There are 9 kids who do sprints only, because 9 plus the 6 that already do sprints makes your total of 15 members who do sprints. Don't get confused by that number. This isn't 15 who sprint only. It doesn't say they only sprint. It says that they sprint, including the ones who also possibly do long jump. That is why it says subtract a little bit. Same thing with the 10 members who are only long jumpers. If there's 10 members, that's a combined with the both and the only. Do you know how many only long jump? If you said 4, you are correct. Which means even though it says 15, 10, and 6, we're really saying that there's so many that are here that we're counting. I don't want to count the same kids. My team isn't that big. I don't have that many kids, so there's a total of the 4, the 6 who are in both groups, and then the 9. That makes a total of 19 students in your sample space. When you go to answer your questions, it's out of 19, not out of all those added together. It's not out of 31, because otherwise you're counting those kids twice. What's the probability of being both? Well, there's 6 out of how many? 6 out of 19. 19 is prime. It's your answer. 6 out of 19 for part B. What about sprinting only? We figured that out. It's this out of 19. 9 out of 19. What about long jump only? It's 4 out of 19. I hope that makes sense to you. The hardest part about things that overlap is that you have to separate that they are going to try to trick you, and those are combined totals, not necessarily the only totals. The next example I have picked for you comes from, I don't know what number this is. It's like 5C maybe? Let me see. Not 5C, the one with the spinner. 2C. Okay, I should have done this one earlier. What is the sample space for the sum of 3 spins of the spinner shown? So if I'm looking at that, there are different possible answers that you can have for the sum of these spins. I kind of want to draw this out just a little bit. If I spin it once, I can get a 1, a 2, a 3, or a 4. If I spin it twice, I can get a 1, a 2, a 3, or a 4. If I spin it a third time, I can get a 1, a 2, a 3, or 4. If you think about the sum, that means adding the numbers together. It could be a 1, a 2, a 1. It could be a 3, a 1, a 4. It could be a 4, 3, 1. It could be any different combination that you have. So when you think about what are the possible outcomes of this sum of 3 different spins, the smallest that it could be would be 3. If I added 1 plus 1 plus 1, that's a sum of 3. The next number would be a 1 plus 1 plus 2, which means I can get a 4, or I can get a 5, and then I think about all the numbers that I could get. But the largest sum would be the biggest number plus the biggest number plus the biggest number, which means we should have sums all the way up to the number 12. 3, 4, 5. I bet you I could get 2, 4, 6. I could get a 6. I can get a 7 somehow. I can get an 8. I can get a 9. I can get a 10. I can get an 11. I can get a 12. My sample space of the sum would be 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. That's your answer for 2C. It's going to ask you some other questions about it, but I figure once you understand that, then you guys are good to go. The last example I have for you before I give you some time is number 7. Number 7 says, is the hardest question that's on this whole worksheet. It says Baskin-Robbins tested 2 new flavors, chocolate, caramel swirl, and raspberry. In a sample of 100 customers, they recorded the following data. 24 only liked raspberry. Then it says the customers that only like chocolate swirl is twice the number than like both chocolate swirl and raspberry. The number of customers that like both new flavors is equal to the number of customers that like neither. We got to figure out what goes in the box. So I'm going to start off by helping you with this question. Box, box, box. Chocolate, caramel, caramel. Tomato, tomato. Some people say caramel. Some people say caramel. And I don't know what's correct. I'm sorry. I always thought that the word caramel sounded fancier than caramel. Makes it sound more delicious. I can't talk about it too much or else I'm going to get hungry. Then we go to raspberry. I guess there's a P in there. I didn't know that. I feel raspy just talking about it. But here's what we know. 24 people only like raspberry. 24 goes there. Only liked raspberry. We know that there is a total of 100 people who took this survey. 24 liked raspberry. The number of customers that liked only chocolate swirl is twice the number that liked both chocolate swirl and raspberry. The number of customers that liked this is twice the number that liked both. Well, we don't know what those numbers are. This has to be twice the amount as this, though. So let's say I don't know what this is. Then this must be 2 times that amount. I put an X and a 2X. This is twice as big as whatever the both is. The number of customers that liked both new flavors is equal, this is the both, to the number of customers that liked neither. I like this, I like this. So if this is both, then out here, who did not choose those must be X. These are equal to each other, the same unknown amount. So what I do now is I figure, well, all these together, there were 100 people sampled. They all have to add up to be 100. So I write an equation. 2x plus x plus x plus 24 should equal 100. Or 2x, 3x, 4x plus 24 equals 100. I subtract 24 from both sides. 4x is equal to 76. Divide by 4, divide by 4. X equals 19. Which must mean 19 people didn't like either flavor. 19 people were both. 2 times 19 is 38. And if we did the math right, 38 plus 19 plus 19 plus 24 should equal 100. Since I've done this already, it does. Once you get here, then everything else should be easy on this question. A customer that likes only raspberry, 24 out of the total of 100. 24 out of 100, put it in your calculator, put it to lowest terms. What I love about the calculators we use in this class is that it does fractions in lowest terms for you. If you put in 24 over 100, press equals, it will reduce it in lowest terms for you. 6 out of 25. That's your answer for the first part. A customer that likes neither, 19 out of 100. That's not going to reduce, it's prime. Customer that likes both, 19 out of 100. So with that being said, that brings us to the end of your notes for 14.1. I'm going to stop your notes right there.